Hello, everyone, and welcome to this new segment of the program, a guide to smart contract development on Stellar using Soroban. By the end of this video, you understand not just what Soroban is, but an overview of how it works at the technical level. Whether you're a blockchain developer, a crypto enthusiast, or someone curious about the future of decentralized finance, this video will give you the knowledge you need. So grab a coffee, get comfortable, and let's dive deep into the world of Soroban smart contracts. Here's what we're going to cover: what smart contracts are and how Soroban works, how WebAssembly WASM powers contract execution, the contract installation and instance model, Soroban storage types and fee structure, how operations and transactions work on Stellar, transaction envelopes, metadata and signatures, contract authorization and invocation, and finally, real world use cases. Before we talk about Soban, we need to establish a solid foundation. Let's start with the fundamentals. What exactly is smart contract? A smart contract is a program deployed on the blockchain that executes automatically when called. Think of it as a digital vending machine. You put money in, select your item, and the machine automatically dispenses it without needing a human operator. Similarly, smart contracts execute predefined logic automatically without intermediaries. Let me break down the five key characteristics that define smart contract. First, automatic execution. When you call a smart contract, it runs automatically. There's no delay, no manual approval process. The code executes immediately based on the conditions you've programmed. Second, predefined logic. Every smart contract contains explicit rules about what it can and cannot do. These rules are written in code before the contract is deployed. For example, a lending contract might have rules about interest rates, collateral requirements, and liquidation thresholds. Third, on-chain state storage. Smart contracts don't just execute logic, they also store data directly on the blockchain. This could be account balances, ownership records, or any other information the contract needs to function. These data persist between function calls and is part of blockchain's permanent records. Fourth, immutability. Once deployed, a smart contract cannot be altered. This is both a feature and a constraint. It's a feature because it provides certainty. Users know the rules won't change midway through the interaction. It constraints because bugs can't be easily fixed. Some contracts are designed to be upgradable, but this requires specific architectural decisions before that is made before being deployed. Fifth, the Stellar specific characteristics. On the Stellar network specifically, smart contracts do more than just exist. They actively facilitate, validate, and enforce agreements between parties. Stellar's design philosophy emphasizes real-world financial use cases, so Soroban contracts are optimized for financial operations. Let me give you a real-world analogy. Imagine a decentralized insurance contract. When someone files a claim, the smart contract automatically checks the conditions. Is the claim within the coverage period? Does it meet the criteria? If yes, it processes the payout immediately without requiring human approval or processing time. This removes friction, reduces cost, and eliminates the possibility of bias in claim processing. This automatic, trustless execution is what makes smart contract revolutionary. They not just digital contract. the self-executing code that lives on the blockchain.